Okay, welcome back, YouTube. Just one last quick uh, video for computer science honors to finish off the year. I'm going to talk about a couple of little things in Visual Python we didn't quite get to do, but we might do next time. Just to recap, this year we did a lot with Sage and Python using the Litvin's Discrete Math book. I think it's Skylit. Their website is skylit.com. I highly recommend this book. This is great. I spend a lot of time in the first quarter, maybe the first semester, in chapters 1, 2, 3, 4, 5, 6, 7. Do a lot of with bits and bytes and changing bases over here. Do a lot with functions and variables and Python over here. We use the first semester we used Sage. Let's see, Sage. Do I have a Sage set up? I think over here. Come on, Sage, wake up. Wake up. Wake up. That's okay. And I have a lot of stuff published on here, like Life at the Calculus, that's me. Like Math 5H, Math 4H, Math 4R, that's me. A lot of stuff on here. Anyway, so that's the first semester. Did I publish a lot of stuff in here for Computer Science Honors? I don't remember now. Yeah, there it is, Computer Science Honors, Chapter 1, Chapter 2. Yeah, so there's a lot of stuff on here. Then we did a little bit with TI-83 programming. We didn't quite get the TI-89 programming. We might do that next time. Then the second semester, we focused on interactivepython.org and turtle graphics. Let's see, interactive. No, it's not there. Interactivepython.org. Yep.
Where are they?
In the box over here.
In the office?
Yeah.
The box?
Yeah. Okay. Excuse that interruption. Let's see. And we used this book. And we didn't quite do all of this. We just jumped around whatever had turtle in it. So I think we started here. And then we jumped in went through all these chapters and just did all the turtle related stuff. And I think we went up to files. No, we skipped dictionaries, we did recursion, and I think that's where we stopped. Okay. And then we started with a little VPython, but we didn't get very far with that. So let's talk about that. I don't need this, I don't need that. So I was looking at some of this stuff. I was doing a little with ballistics, with just a vertical component of motion, and then a horizontal one. Sort of, with a la Galileo freefall model, and then we did sort of like a cannon, and we had a cannon with the crosswind, and I played around with this a lot. Then I didn't get to do this too much. This is all inspired by ericthompson.com, by the way. And then I didn't get to play with this too much, but I'm thinking of playing with Hooke's law and the spring constant and tension on cables and stuff, and orbits and things. So let's see how this works. Here's ballistics 1. There you go. So it starts off at 100 meters and comes crashing down, and then it stops. Okay, good. So let's see, where was that code? So we have a sphere starting at 102 meters in the air with a radius of 2, color red. The box is like the ground. It was orange. We have 9.8 meters per second. The T0 is 0 seconds. This is all in seconds here. Well, not finished. Finished starts as false. Rate 100. That slows down the loop a little bit. And we have negative gt squared over 2 plus v0t plus y0. But v0 is 0. vy0, I guess I should say. And then it prints out the time and the position, or vertical position of the ball, and it gets updated every 100th of a second until it hits the ground. There you go. Here's the second one. We changed it a little bit in that we have it falling off of a building, and it has an x and a y component to the velocity. Let's see how that one works. Run that. There you go. So it has a certain initial Vy0, Vx0. There you go. We're not talking about air resistance or friction or anything like that. We could get to that, I suppose. All right, then what's number 3? Number 3, we just give you a vector, a velocity vector and an angle. This one starts at with the initial velocity of 40 meters per second and initial angle with the horizontal is 80 degrees, which is converted to radians. And then we talked about not only the position as a vector, but also the velocity as a vector. All right, see how that works. Starting from the ground. Where is it? Here it is. Bing. There you go. Printing out all the x and y coordinates as it gets updated automatically in VPython. And it hits the ground and it stops. By the way, you can zoom in, zoom out, we can flip it around. Notice how it doesn't change in the z direction. Nothing changed in the z direction. All that changed was in the y direction and in the x direction. Okay. Take a look at number 4. Here we threw in, we have a velocity vector for the throw and a velocity vector for a crosswind, and then the total velocity vector is the combination of the two. Is the resultant when we add the two. And so we're dealing with x, y, and z coordinates for position and vx, vy, vz. Right, so v total.x, v total.y, v total.z, right? And let's see how that works. This is number 4. Run that. Dun, dun, dun. Now notice there's a z component to the velocity. So it's going off to the side here. Also, the wind, look at what the wind was. In the x direction, 2 meters per second, in the y direction, 1 meter per second. So it's pushing it to the right and up, and then to the left. This is the z direction. All right, then, I didn't really get to play with this too much. I just took this off of Eric Thompson's website, playing around with springs and Hooke's law and spring constants and force as a vector. And let's see how that works. Where is the spring? There it is. Whoops. Wait, I thought I ran this. What happened? Didn't I run this? Properties. Permissions. Ooh, this must be a new copy. Hang on. I didn't get to test this. Hopefully this works. Drag, wait to start. Bing. There you go. That's interesting. Very nice. Alrighty, I didn't get to go through this code too much yet, so I'm not going to explain it right now. There's just a little brief note to self of stuff I'm going to do in the future with this course with Visual Python. Alrighty, so that's spring.py. Where did that go? Let's look at that. There's spring.py. Okay. Now tension.py. Now look what this does. You can add 1 gram at a time to this weight and see if we can pull this weight down. Don't mind those pings. Those are people logging into my blog. So 1 gram, 2, 3, 4, 5, 6, 7. Notice it's updating the mass on the string, the tension, force. Another one, another one, another one, another one, another one, another one. We're up to 33 grams on this little mass here. No acceleration of the book, no acceleration of the weight, no distance of book traveled, okay. Bing, bing, where is the threshold? 38 grams, 39 grams, 40 grams, 41, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. What am I saying? 57 grams, 58, 59, 60. Oh, there you go. That was the cutoff right there. Alright, so we're done. A little x direction of the acceleration, a little y direction of the acceleration. Distance, horizontal distance for the book, and vertical distance for the weight. Okay, nice. And then playing around with orbits and gravitational constants and stuff like this. Wait, hang on. Did we show the tension? Yeah, again, I didn't go through this code much yet, so I'm not going to explain it yet right now. And then here's the orbits. Take a look at this code. Talking about Earth's mass, and the mass of the moon, and gravitational constants, and gravitation, and fun stuff. So let's see what that does. Run that. Yeah, it's sort of hard to see it here. Let's zoom out, zoom in, zoom out. I don't know if you can see that, but the moon is like slingshotting around here, showing Kepler's laws work as you get closer and closer. Velocity goes faster and faster as you get closer to the Earth there. I don't know, can I do, yeah. There you go, that's that. Okay. And what I'd really like to do is see a lot of interacting orbits, like an n-body problem. And I have an example of that in here. Let's see, file, open, in VPython. They have a simple orbit program here. And there it goes. So, zoom out, zoom in, flip it around a little bit. Alright, there you go. Play around with that. But this one's really interesting. Look at this one. A whole bunch of them. Let's see, I think it's stars. A whole bunch of planetary orbits going on. Whoops, where am I? Run. Look how nice this is, huh? Look at that. And you can see how as the bodies get closer together and the bigger bodies and little bodies, they affect each other. They change their orbits. I think it's set up if they collide that the smaller one disappears or something. I'll zoom out a little bit. Isn't that nice? That's cool. So this blue one is still being brought in by the I guess the total mass of the system. Right? Sort of like some kind of a cometary orbit going on. And these are planetary. This one's gone. Goodbye. Where's that yellow one going? Where is he? He's way out there. That's cool. And if these are coming back, crazy stuff, right? So I'd like to get into stuff like that. That's crazy. Let's see. There's some nice code going on here. Arrays and vectors and Newtonian stuff. A list, I should say. And okay, so that's all, folks. I think that's a little summary of stuff we have done, stuff we're going to do. I don't know if we're running this course next year. If we run it in a couple of years, we might record some new stuff related to this VPython thing. Alrighty, so there you go. So first semester was the Litvin book plus TID3 programming. So Sage, Python, and TI Basic. The second semester was more of the interactive Python with the turtle.py and a little VPython. And we'll do similar stuff next time we run this class. Okay, so thanks for watching. Have a nice summer. See you next year. Bye-bye.